One important concept in understanding certain types of chemical reactions is solubility. We discussed solubility previously in terms of defining it as a very common property for ionic compounds. However, the statement that all ionic compounds dissolve in water is a very general statement. Many ionic compounds dissolve well in water, however, some dissolve very poorly or not at all in water. We have to use something called a solubility table to determine if an ionic compound will actually dissolve or not. If you turn to the back of your periodic table, you will see this. This is on the back of your periodic table. And this is called the solubility table. We're going to talk about in just a moment how do we use this table to determine if an ionic compound actually dissolves in water or not. Now, one important definition, we've talked about this previously, is the term precipitate. We're going to use the solubility table to determine if a product of a chemical reaction is an actual precipitate. A precipitate is defined as an insoluble ionic compound that is the product of a chemical reaction. We're going to talk about one specific type of reaction that produces precipitates. Before we do that, let's talk about how do we actually use the solubility table. Okay, let's go to the table and let's look at how it is organized. Solubility table, on the left side, the left column here, lists the rules for certain groups of compounds. There are 8 rules. One important thing to note is that the rules are listed in order of their importance, and a rule that is listed up higher will overrule one of the rules farther down that might seem to conflict with it. I'll give you some examples of that. The right-hand column lists very important exceptions to each rule that it is next to. So, for example, rule number 1 says that all nitrate, nitrite, chlorate, and perchlorate salts are soluble. The term salt is another word for an ionic compound. You'll see that very commonly. So you will need to say, so if you have any compound that has something NO3, something NO2, something ClO3, or something ClO4, it's soluble, which means it will dissolve. Over here are 2 exceptions. Silver nitrite and potassium perchlorate are generally considered not to dissolve very well in water. Okay, rule number 2 talks about all of the alkali metal salts. Right? Alkali metals will have Li, Na, K, Rb, or Cs, the first metal in the compound. And ammonium. Remember, ammonium is the positively charged polyatomic ion on the back of your table. All of these are solubles, and please note right here, this is blank, which means there's no exceptions. Rule number 3 talks about the halogen compounds. Halogen salts, any ionic compound that has halogens, are soluble. There are a bunch of exceptions here you have to be really careful with. So if you have silver with one of these, lead +2 with one of these, okay, this little funny guy, which is actually mercury 1. This is a very interesting and kind of oddball diatomic metal polyatomic ion kind of thing. Copper 1. This is thallium. Sorry, that is titanium. And lead halides, it says right here. A halide is another word for a halogen salt. Those are soluble if in hot water, but they don't dissolve when the water is cold. Okay, and HgBr2 is specifically not a soluble compound. So you have to read them very carefully. If you look and you say, okay, I've got chlorine in my compound, and you say, okay, that has to be soluble, then you have to double check and say, do I have chlorine paired with one of these? Then it's the exception, which means that it is not soluble. Rule number 4 says most acetate salts are soluble, with the exception of silver acetate and the little funny mercury 1 acetate again. Number 5 says that most of the sulfate salts dissolve, except for calcium sulfate, strontium sulfate, barium sulfate, radium sulfate, lead 2 sulfate, silver sulfate, and this is mercury 2 sulfate. Okay, then 6, 7, 8 are kind of the opposite. These talk about ones that don't dissolve. So for number 6, a lot of compounds that have sulfide in them do not dissolve. Okay, however, if it has an alkali metal or an alkali earth metal with a sulfide, those dissolve, and ammonium sulfate dissolves. Okay, number 7 talks about compounds called borate, BO3, carbonate, CO3, chromate, CrO4, phosphate, PO4, and sulfite, SO3. Those usually don't dissolve. Okay, however, magnesium chromate does dissolve, and any alkali metal, remember that's lithium, sodium, potassium, etc., those all dissolve. And then lastly, number 8 says most anything with hydroxide in it doesn't dissolve unless it has an alkali metal with it. So that means that sodium and hydroxide, and potassium and hydroxide, and cesium and hydroxide, those will dissolve. Alright, what we're going to do now is we're going to do a couple of quick examples. Alright, so let's start with magnesium hydroxide. Hey, you're going to have to practice your nomenclature again. When you do solubility, you'll probably be given a name, you're going to write the compound, and then you're going to have to predict if it's soluble. Alright, so when you look at one of these, you have to ask yourself, what is in the compound? The compound is made up of magnesium, and the compound is made up of hydroxide. So we're going to go back to our solubility table and look for something in a rule that talks about magnesium in general or hydroxides in general. And then we'll make a decision if it's soluble or not. Alright, let's go back to our solubility table. Okay, now we're going to scan down the rules and look for anything that talks about magnesium on the left side or hydroxide on the left side. Okay, nothing about magnesium, nothing about magnesium. Okay, hydroxide. And as the rule says, most of these are insoluble. They do not dissolve. So now we'll check to see if it's an exception. We have magnesium hydroxide. Now magnesium is not an alkali metal. It's an alkali earth metal. So that means it is not an exception. Okay, so it will follow the rule for hydroxides. It will be insoluble. It will not dissolve. Okay, let's look at another compound. This is sodium, and SO4 is sulfate. So when we go back to the table, we're going to look for something that talks about sodium and or sulfate. Now this is one rule where it's really, really important that you get very, very comfortable with the idea of starting at the top and working your way down. Okay, look here and you say, oh, sodium. And then you say, ooh, sulfate. Well, which rule do I use? You use the first rule that you encounter always. So there's a rule for sodium, and it says those are soluble, no exceptions. So sodium sulfate, excuse me, is a soluble compound. Okay, let's do one more. Okay, this is nickel 1 sulfide. So we're looking for anything on the left-hand side that talks about nickel and talks about sulfide. You come down here, and you're like, sulfide. The rule says sulfides are insoluble. They do not dissolve. Now there's exceptions, so we'll check to see if nickel is mentioned in the exception. Nope, nickel is not over here, so the rule will be followed. So this is an insoluble compound. Okay, so that's all you need to do for solubility. Okay, just be very careful when you use the table that you look up, you kind of look down the left-hand side for a rule that talks about the compound, or one of the ions that's present in your compound that you're looking at. Make sure you start from the top and work your way down every time. Use the first rule that you come across, and then just double check to see, is whatever my ion is paired with, is that mentioned in the exceptions? If it is, okay, then it'll be the opposite. If it is not mentioned, then the rule will hold.